Hey, so this is going to be a short presentation about the server-side apply in Kubernetes and how we could use it in our operators or not. So server-side apply is a basically evolution of last apply configuration and various ways that patches can be applied in Kubernetes. It happens on the server, not in the client, and it's quite easy to use from the client side. And so when it merges stuff, it considers four things: the current state, obviously current state of the object as it exists in cluster and the page itself, but it also takes into account the schema of the object, so which enables certain advanced things when merging stuff, especially arrays. And it also records the ownership of individual fields in the object, which again enables it to do quite neat stuff that we'll look at later. So this is going to be one long demo. So let me first start watching our resource. No, we are going to be watching a config map that we'll do our experiments on, and currently it doesn't exist. So as is the case with kubectl apply, there is no difference between create and update when you're uh, working with SSA patches. So if we have this config map and we want to apply it to the cluster, as we would do with kubectl apply, we don't care whether it exists or not. We just apply it to the cluster using a client apply patch, and we set the owner to us. So let's try running that, and you can see that the config map was created, and Alice is recorded as the manager or owner of the key in the map using this field structure that basically points to this key. So yeah, the metadata managed fields is used to record the ownership of individual fields in the object, and it supports a recording the ownership of structure fields, map keys, as we see in here, because data is in a config map is basically just a map, and we can record ownership of individual field keys in that map. And also, if the schema defines an array as a set-like array, that can hold no duplicate values, it can also take record ownership of individual fields in those arrays. By the way, this setup is usual in our CRDs and basically all across Kubernetes objects. So yeah, let's try this. We have this patch that basically says that we want a different key be present in the map, and this is being done by someone else, by Bob, and Bob just applies this config map without knowing what's already present on the server. So if we apply this, you will see that now the map has two keys, the original one that Alice applied, but also the new one that Bob applied, and each of them is recorded as an owner of their individual keys in that map. So basically, yeah, this is a patch. It's not a full-scale update. So you don't have to have the idea about what the full object looks like, and you can distinguish between values of different owners. This is for now it's not important, but it will become important later on, as you will see. Um, one of the consequences of being able to record the ownership is that different owners cannot step over each other's toes, which is actually not the way we should be using it in controllers. But never mind. Let's take a look. So right now we want to update our config map, the key that is owned by Alice, and we want to apply a different value to it as Bob. So if we try that, we will see that the apply failed uh, because it conflicts with Alice's value. Another feature of this is that the ownership can be shared. So as long as a key or as long as a field has the same value that's agreed upon by all owners, then those owners can all share the ownership of the field. So if we want to apply this patch, that's basically the exact copy of what's already in the cluster as Bob. We can do that because the ownership can be shared. So you can see that Alice is the owner of the key, but Bob is the owner of both key and my key. Yeah, this can become useful when there are multiple managers or controllers that collaborate on a single resource, and they want to make sure that they agree on certain values. The ownership also can be forced, which just will reassign the ownership to whoever is forcing the update. This is useful, and mostly this is actually what's recommended for the controllers to do, because if they really need to make sure that a resource looks a certain way in the cluster, then they need to be able to enforce those values. So they will usually force the ownership and therefore force the state of the resource to be the one that they need. So it looks like this. We will just add another option to the patch and the code. If we want to update our resource to look like this, basically have the key having a new value and my key keeping the same, and we want to do all that as Bob, and we are forcing the ownership, then if we do that, you will see that Bob is now the sole owner of all the fields in the config map. There's no record of Alice being owner of anything. If yeah, if we only use SSA to update the values, so there is no create or update or anything, then if certain set of values is only managed by SSA, then the deletion of those keys is also taken care of by a single update or SSA patch. Sorry. So now Bob is the sole owner of both key and my key entries, and he's done all that using SSA apply. So if we now send this patch that only contains the key entry, and we doing it again as Bob, then you will notice that my key is no longer in the map. It was automatically deleted because Bob was the sole owner of my key, and he just sent in a patch that didn't contain it. So my key was deleted from the map. This is great if you basically want to, if you are managing certain fields and they can change in a number, so you can very easily, update update them without needing to keep track of what field to delete, what field to update, what field to add, etc. Now, managed field is used not only for SSA, but also for regular create and update calls. So if we recreate this config map, but this time we use ordinary create and not an SSA patch, you will see that Alice is again recorded as the owner, even though this was not an SSA patch. Managed fields was populated basically by the whole contents of this config map, and Alice was assigned as the manager because we said so. But the operation that this was not an apply, but an update. As we said previously, create and update are the same thing. So create and update are recorded as an update in managed fields. This becomes kind of harder to work with when you try to mix the two approaches using the same manager, basically. So if you are, again, as Alice, try to apply value using a server-side apply that you previously created, you will see that the apply will fail because there was an update or that updated the same key to a different value. And even though the manager, the owner, is the same, this will not go through, which is kind of a shame, but that's how this works. Of course, you can force it so this would go through if you apply this by force. The strange thing is that if you do an apply for another key, so as we saw previously, if you do an apply patch and do not mention a specific field in your patch, then that field will be deleted from the server because you are the owner of it, but you're not mentioning it in the patch, so it will disappear. This is not the case if you are mixing apply with updates. So if we try this here again, we will see that key actually was kept in the object, and the ownership looks like this. Another key, the one that we just apply using SSA, is owned by Alice, and was the operation that applied it was SSA. But key is still owned by Alice because the operation that applied it was a different one, was an update or create. So it's not recommended to mix the two approaches because, yeah, unless you're forcing it, stuff can enter into weird states. So the way around this is basically to migrate. If you're using create and update, and you would like to start using SSA apply, then there is a need to migrate the object or the managed fields of the object to reflect the fact. kubectl that and does that automatically because it takes a look at the last applied configuration, and therefore it sees what kubectl is supposed to be the owner of, and if you apply an SSA patch using kubectl and it sees that the resource was managed by kubectl previously, but using normal operations, then it will automatically migrate the managed fields and will remove the last applied configuration, I think. So that the kubectl entry in managed fields is not a mixture of apply and update, but only apply or only update. So if we were to use this approach, I think we would need to do a similar kind of migration. Yeah, we already did this. So why we would want to use SSA in controllers as opposed to just the normal, get, modify, update workflow that we use now? The main reason for it is that uh, when there is a lot of churn in the cluster or when there's multiple controllers working on the same resource, you will get, as we know, uh, the errors stemming from the fact that the resource was updated since the last time you got it. So that basically uh, results in a repeated reconciliation, so which can be kind of costly, and so this can result in a lot of additional work until the two controllers basically are perfectly one after the other, and their reconciliation times don't overlap. So this can be largely avoided by SSA because each controller is responsible for a certain part of the resource. They don't have to, and they don't need to know about the rest of the resource. They apply the patch to their respective parts, and that, and when they're forcing it, it never, uh, it never fails the patch. It can still, result in repeated reconciliations if they step over each other's toes and update the field, update the same field, both of them. But yeah, that's the usual thing that should not happen, but happens sometimes. Uh, if you want to use SSA in the controllers, given what we just saw, that especially the automatic deletion of the entries that are no longer present in the patch, um, you have to ensure that certain things are true in when you're using SSA in your controller. And the main one is that you always need to set all the fields that you want uh, in the resource to exist. You cannot just update a single field and be done with it, because that would mean that all the other fields that should exist on the resource would be deleted. So you always need to make sure that everything that you set on the resource is always set to to the value it should be. And you can either enforce it or ensure this fact in your business logic in the controller, or you first get the resource, somehow convert it into a patch, then modify only the things you want, and then send out a patch. For the latter approach, basically you get the resource, you make it into a patch, you modify it the way you want, and then you patch the resource. For standard Kubernetes objects, there's nice support for this in this package. Basically, you get the resource, you extract the patch out of it. Basically, this will look at the managed fields and will see all the fields that are owned by your owner, and will create a patch out of it. You can then further modify the patch and then send it out as a patch to the cluster. So this is done for the standard Kubernetes objects, but there's no support for this for CRDs yet. You would either have to, hand roll it, or we will need to wait until controller gen supports this. There's a PR open for this. That's not still merged. So how to use the SSA in controllers? I think for now, the answer is just don't use it yet. We should wait for better tooling and basically for more experience with this in the community and within our teams as well. And the question is why we would want to use SSA in Kubesa for templates. And I think the answer is that the features that the SSA offers is a exact match for what we want to do in our uh, template application logic. We tried to replicate basically what kubectl apply does, and we ended up with something quite complex that basically exactly mimics in features what SSA supports out of the box. The fact that we can update just the fields that we care about to the exact values that we want without affecting the rest of the object, the rest of the fields in the object. The fact that if our template changes and we apply that changed template to an existing object in the cluster, it will automatically remove the fields that are no longer set by us. All this logic is exactly what we want. So it's a nice fit for that, as opposed to the controllers that are still not yet ready for this, I think. And here are some links to learn more about SSA in Kubernetes. I tried to get some insight using ChatGPT and other LLMs, and it was not that great because I think it being quite new feature, there's not a lot of stuff on the internet talking about it. So SSA LLMs get a little bit confused about it. So that's it for now. Hope this was useful, and speak to you later.